So in the last part we did up to this, and now we are going to minimize this function. Okay, so we did up to this starting from. Okay, so now how we go about writing this. Okay, so let's write again what we are how to minimize. So z of r is 10,000 k upon r plus q of r by 2. Now how we will minimize? Okay, so we will use the tool from calculus, which is of course derivative. So to minimize this, we will take the derivative of a function. Okay, and yeah, that's easy to do it. Now, so next step is our to take the derivative. Right, so you know that to minimize a function or maximize, we take the derivative. Okay, so we will find its slope and again then set the slope equals to 0. Slope like okay 0. So where our slope is 0, it's the point where the function is minimum or maximum. So we'll write z of r is z prime or dash of r is equal to, so this is just a constant term, also this, so 10,000 k into 1d derivative of r 1 by r. So sorry for this is derivative of 1 by r with respect to r plus constant q will come out, and also 2, and then we just take derivative of r with respect to r. So let's rewrite z of r, z prime of r is equal to 10,000 k into plus, okay, so I will write, now let's take the derivative. So the 10,000 k constant, now derivative of 1 by r, so like derivative of 1 by x, if you know, is minus 1 by x square, so derivative of 1 by r is minus 1 by r square, so minus 1 by r square plus q by 2 and derivative of r with respect to r. So since this r is just simple r, if I am only talking about r, is just a simple linear function, so its derivative is just going to be 1, constant slope 1, so 1, or the derivative of x with respect to x is 1. So we get 10 minus 10,000 k by r square plus q by 2. Okay, so now let's now what we will do, now we have find the derivative. Our next goal is to minimize the function, but before that just simplify a little bit. So like we'll a little bit simplify this, so minus 10,000 k times 2 plus q times r square, and this common denominator, taking common denominator, this is minus 20,000 k plus r square q divided by 2r square. Okay, now we have find out the derivative, simplified it. Now to minimize this, we will check where the derivative is 0. Okay, so put z of r equals to 0, so 0 equals to minus 20,000 k plus qr square, okay, 2r square multiply to 0, it's 0. Okay, now well, okay, now just find r, so QR square equals to 20,000 K. Solve for R. Okay, so R square is 20,000 K by Q. Therefore R is what? Root 20,000 K by Q. Oh, so we have find out they are where R is minimum. Okay, now let's see that what was our K, or I should say, sorry, not K and Q are just our obviously constants. Okay, now we can write this. Okay, so what we have, 20,000 times K by Q, R equals to, now what was our A? So we assume A 10,000, so we can also write this like 2 times A times K times upon Q, and this is the final formula. Okay, you can use to find economic order quantity, or R. Okay, so this is the point where our OC and CC is minimized, and we have obviously proven that and how it's minimized. Okay, so now I will show you the graphical graph. Okay, now that how this looks like and how it's minimized there. Okay, and what we have done by doing like this, taking derivative. So I will show you graphically now. So let's see. Now we can take some values and let's find out for some values. Okay, so suppose A was 10,000, so let's assume our ordering cost, which is just K, not ordering cost, but let's say our K constant is, okay, so it's like ordering, if we look at ordering cost, see, if you look at ordering cost, so just K times A upon R. So K you can think just like per unit. Okay, I already explained you. This is like the constant by which the ordering cost will increase. So suppose K is 100 and Q is suppose 8, so R is 2 times 10,000 times 100 upon 8, so R is, okay, so now you can solve 2 times 10,000. So if you solve this, R is 500. So this is the quantity, so this is the quantity that should be placed each time. Okay, so next we will do graphically, and also I'm thinking to write a simple program to find carrying cost and to find economic order quantity EOQ. So it's just going to be a simple basic program, and just do it in a seconds. Okay, for any value of R, or sorry, A, Q. Okay, so let's see.